Okay. Hey everyone, this is the April 22nd edition of the 9 a.m. PST edition of the Karpenter Working Group. Thanks everyone for attending. I posted the working group blog in the chat. Feel free to add any additional items to that working group blog. We're obviously in the 422 section. I'm going to go ahead and share my screen as well. We can go ahead and get started. Yeah, and also if you're an attendee today, go ahead and add yourself to the attendees list as well. There's a couple other sections below here. There's any RFCs that are open that you want us to discuss, you can add to the bottom. And then any community questions or things that we should call out, feel free to add those as well. For project updates on the AWS side, we did I guess also on the upstream side, we did a V036 release. That one had some minor feature improvements, some performance improvements. We hadn't done a minor version release in I think about 2 months. So there were quite a few commits in there. A lot of them were bug fixes, but we weren't releasing off basically we weren't cherry picking on it. So we did minor version release. So the biggest things to call out from that release are the ability to select by CPU manufacturer if you're running on AWS. You can now do that. And then the second thing is we had a bunch of performance improvements. So things around how quickly we re-reconcile. There is now the change that if you specify your API version API version in kind attached to your node class reference, then you will get quicker reconciliation for node class drift checking. So anything that is checking based off of the spec in the node class will now be quicker. It should requeue rather than waiting 5 minutes, or at the most, I guess it was before it was 5 minutes. So that's improved, and then there were a couple other drift bug fixes with things we weren't reconciling on that we needed some other work in place to be able to, or I guess we weren't doing the accurate drift checking on it, but we needed some other work in place to be able to actually do that accurately. So that also got merged. A couple of those things are minor, mostly having to do with an issue with the way that we were hashing a couple of the fields in our spec that were, I guess, unexpected in the way they were being hashed. So those are fixed now. Aside from the release, probably the biggest point of interest, I'd imagine, of things that are being done by the maintainer team is the Karpenter V1 RFCs. Those are still in progress, but they're getting finalized. So I think that I'm hoping that we'll be able to have something out over the next week or two, hopefully by the next working group meeting. So that would be, I think that's going to consist of 2 different docs. There's going to be a V1 API doc, and then there's going to be probably a V1 feature list doc that's going to be separate from the API to kind of break it out a little bit easier. That's it for project updates. Moving on. I don't see anything in the RFC section, so unless somebody speaks up now, you feel free to interject if you want, but unless somebody speaks up now, we can move on to the community questions.
Sorry, I didn't add it here, but I had an RFC for global Karpenter limits that I'd love to discuss if there's time.
Yeah, sure.
I can pull that up. I think I still owe some work for updating this. I originally started with adding a flag or a startup flag to Karpenter, but got a few comments that this should probably live as a new CRD potentially. But the goal here is just to provide a global limit on the number of node claims, or more broader, the number of resources that are provisioned for a Karpenter cluster.
Do you mind walking through? I haven't had the chance personally to be able to read through this. I need to take the time to read through this, but just walking through why you want this and the current limits don't quite fit your use cases.
Sure. So currently, when you build a Karpenter node pool, you do have the ability to specify limits there along whatever is really given back on a node claim. So I think you could even limit on like pod ENIs, but for now, like for the most simple case, we can think like CPU and memory. And then that will allow you to like cap the number of resources that a node pool is gonna be provisioned under a given node pool. But if as a cluster operator, let's say I have two dedicated node pools for two different teams, and um, I have a cost limit that I'm trying to abide by. There's no real way to potentially allow, like the only way for me to run that is then to allocate each one of those node pools half of that spend, let's say. There's no way to basically give a shared pool and let them both scale up to whatever my limit is. Another use case could be so I included it here on number 3, but someone else had mentioned it of there's some CNIs that just have a simple max limit on the number of nodes that are supported. So it'd be ideal if instead of having to apply 200 limit on each one of those node pools, if I could just apply a global limit of 400, and then Karpenter will just stop provisioning new nodes whenever I hit that cap. Hopefully that makes sense. I can go deeper or provide some more context if you'd like, but my specific use case is I'm running in some of my clusters, we have limited IP space, so we just want to have a way to limit the number of nodes that Karpenter provisions. And they're pretty dynamic in the instance types that they choose. So I'm not really concerned about specific like CPU or memory limits, and that would require me to limit the instance type choices that I have. And it'd be nice if there was just an ability to limit the number of nodes that are provisioned.
What's the specific, like, what is it typically IP based issues with the number of nodes, or is it mostly like API server calls that are causing you to want to limit the number of nodes on a given cluster?
My use case is IPs, but some CNIs just for number 3, I'm not sure what the actual limitation is there, but my specific use case is number of IPs.
Yeah, I'm curious. I guess just from like, oh, okay, I'll let Garvin go ahead and guess and see where it's at.
Oh, sorry. I was gonna ask,
Hey.
like, I don't know if it's gonna be a similar question. Like, what do you expect to happen when you hit the limit for IP? Like, stop spinning out nodes, or you want the Karpenter to recalculate and be like, oh, you should bring up these nodes instead because you can hit a higher IP, or this is a hard stop, no more increasing of nodes, period, after you hit the limit.
Yeah, exactly that. And I don't want to sidestep the discussion there, but I will say, like, just to maybe make it simpler, like if we could just think about number of nodes, or maybe like another use case here is to go back to the initial example of, let's say, or not the initial example, sorry. Let's say I have a set of node pools that sorry, I'm trying to think of a better way to rephrase that, but yeah, to answer your question, I would expect Karpenter to just stop provisioning nodes once that max limit has been hit.
So what happens? So it's interesting. It's definitely more dangerous than the standard node pool limit behavior. And definitely like you get those design questions once we hit the edges, I think. Because now you have the question of like, okay, consolidate, like, do you consolidate based off of limits? This is kind of a separate question that's being had in a separate discussion because somebody else asked for that feature request, which is kind of is a tricky bit for different reasons. But like in the case that you have a global cluster limit, but you have new pods that are added to your cluster, like, do you take a hit on cost, which is not the way the consolidation happens today, but do you take a hit on cost to be able to schedule those pods to be able to be under your node cluster limit? Like reasoning in terms of nodes is I guess it's tricky for that reason. It's a little bit of it's a divergence in a way from like the way that we've thought about at least consolidation fundamentally, but also I think it's a bit of like ideally I think it would be nice if Kubernetes didn't even ask you to think about your capacity that you underlie and like that's underlying your applications to some degree. I mean, obviously in reality, that's not the case, but like at the end of the day, what you care about is you're scheduling your applications and the nodes that are like underlying those applications, like you care about their hardware requirements for your applications, but you probably don't care about like the amount to some degree. I mean, you care about the amount only because the CNI kind of has forced you to think about the amount of nodes that you're running. I guess I'm curious, like, rather than Karpenter having to enforce this, and I'm not against this proposal, I'm just like, rather than Karpenter, because I think the cost limit is kind of interesting. But like, rather than Karpenter having to enforce a node limit, which we kind of generally pushed against just because of this concept of like, most of the use cases have generally been around like API server traffic, I can kind of understand. CNI limitations, I'm just curious if the CNI can do things that would make this limit less hard for the number of like IPs. Like what are the limitations on the CNI and like is there work the CNI can do? I don't know which CNI are you using, I guess.
VPC, CNI, and Cilium. But that's a very valid point, and I definitely think you're right in that CNI could be doing more things, or this could be handled in other ways, and maybe not something that you want to take on in Karpenter, because I think someone else also called out in one of the feature request issues, maybe that this could be solved with a policy engine. So that's actually how I'm doing it today. So like I run Kiverno, and then I just have a check that would basically just wouldn't allow Karpenter to launch new node claims after a given limit has been hit. So like that's totally another way that this could be addressed, and it could be pushed down to the users. But if I could just ask, so like, so you, the Karpenter team, wouldn't suggest that teams have any global limits, or like, let's think about limits that are already supported, like CPU and memory, for example. Is the suggestion that we keep those always at the node pool level, or
I guess we can frame it this way. Like, how's that working for you? I guess my concern would be that if you're at the edge of that behavior, that you're now going to like fail to schedule anything because you're at your global limit and Karpenter can't reason about. I guess CPU memory is a little bit easier. Node count is a bit more difficult for the reason I called out. Like Karpenter now has to like be aware. Like if you have a bunch of small nodes, you can hit your limit. And then now you've got a bunch of pods that don't schedule, and Karpenter's not going to do anything about it today because it's not going to be aware of the fact that you have a bunch of small nodes, and it should actually make them bigger so you can actually schedule everything because you've run against your limit. I guess CPU memory is more likely to give you success, I would imagine, because you can tangibly map that back to application pods. But like, do you hit the edge of your limits often, where you just have pods
no,
fail to?
no, not often. And we just have alerts based on it. And when we do, we just know we typically some manual action would be involved there. It's literally just a safety check if because some of our clusters are just running in shared AWS subnets, and just to prevent us stepping on other infrastructure mostly. And the proper fix there is to not run in shared subnets properly.
Yeah, I'll need to read through it a little bit more. Yeah, I think it's interesting. I guess my knee-jerk reaction to global cluster limits is often like I guess I'm curious what you I guess the main thing, okay, so it's like if you've got application teams that are managing your node pools mainly, right? I mean, it's like you don't have control over the infrastructure layer, or at least the configuration layer, basically. Like there's you have persona isolation between like who's managing the cluster and who's managing your node pool. So do you vend out like the ability for application teams to be able to create their own, or maybe like an organization to be able to create their own node pools to be able to configure the hardware requirements they have?
For specific clusters, yes. I mean, yeah. We typically also have ownership over like whatever repo that we're configuring that through. So we have some oversight, but Yeah, that's typically what I'm talking about.
Gotcha. Okay. Super interesting. I've definitely heard this from a couple other people. I think we've had some conversations about it. I need to kind of refresh my own memory on I guess the edgy behavior about it. But I'll take a look. I know it's kind of, there's already been some Bryce's provided some input already.
I was going to rework this to mostly focus on rather than a startup flag, but also be inclusive of just broad global limits. But I at least wanted to come here to discuss whether or not that's even something you would entertain. But it sounds like your initial reaction is to not. Is that
Yeah,
accurate?
I think we should explore the use cases and really understand, like, I mean, I think you've laid out a few here, obviously, but I think we should explore the use cases to really understand, like, if it's needed or if there's work that needs to be done in other components. I'd be less concerned. I know there were a lot of comments on like API, but I'd be less concerned on the API surface right now. Like, it obviously matters at the end of the day if we choose to accept a feature, but like, I think right now what's important is that we like understand where that, like, what the problem is, which I think I think you understand the problem, and you've laid out. Again, I haven't read this, so I'm assuming you've laid that out pretty well. And then understand like which component should be responsible for ensuring that like thing that isn't currently insured is insured, so that you don't have to deal with this problem. And maybe the answer to that question is Karpenter, but I don't know yet. But like I think if we can figure that out and flesh that out, which we can either have discussions in the Slack or on the RFC, then we can get into the API, like assuming that we know where it should be. That's at least my take.
Okay. That's fair. Yeah, I'll add some more detail. Yeah, I'll keep the discussion on. Thanks for going through it.
Yeah. If anyone's, I don't think anyone's taking notes, but if anyone wants to add like maybe a summary of the discussion we just had as well as the link, that'd be helpful. Maybe Jason, since you're on the maintainer team. But okay, DRA working group. I just wanted to call this out personally. There's some work that's happening. I don't know if anyone's subscribing to any of the Kubernetes dev threads or the SIG node threads or anything. You probably you definitely know about dynamic resource allocation. And it was a big hot topic at KubeCon if you were there. So the working group that was originally, I guess it was in SIG batch originally, if I'm recalling correctly, that was originally started around or no, it was SIG node, sorry. So SIG node was originally starting this discussion around dynamic resource allocation, which is basically a new way for the Kubernetes resource model to be reasoned about. It has some overlap. It has quite a bit of overlap actually into how both cluster autoscaler and Karpenter reason about resources that don't exist. So for Karpenter, I guess the problem is twofold. Today, cluster autoscaler supports this like scale from zero scenarios for extended resources. And this kind of gets into the edgy territory that Karpenter has today, which it doesn't have an ability to reason about extended resources, which is like a separate design question on its own, which is how does the user define extended resources for Karpenter to utilize and know about for a given instance type, especially if that isn't well known in a way that like we can like NVIDIA GPUs is kind of an exception, I guess, to some degree, although it isn't in some ways because it is so common that we just kind of assume that like if you have you have the plugin and you have the driver on the node so that resource would register in pretty much all cases if you're launching a GPU instance. So we kind of like first class support for that, but there are cases where, and potentially we can first class full support for all the common extended resources, although I don't think we can necessarily be exhaustive with it. So anyway, the extended resource problem, which we've talked about in a few different discussions, and I haven't tracked down there is a document. I'll track it down and add it to the working group log unless somebody wants to add it during the meeting. But basically, there's a discussion on extended resources, which we need to solve in Karpenter. There's the separate discussion on dynamic resource allocation, which is happening in upstream, which is a separate question. Which is about how like you can provide more extensive ways to do selection on hardware requirements that you have for your applications, mostly in the context of AI ML workloads, but I mean, there are potentially some other use cases for it. This discussion is happening, I believe, every other Tuesday at 8:30 PST. If you're interested at all, and you're interested in like how that overlaps with Karpenter's requirements and how it needs to be able to understand the new way that potentially that's coming in upstream Kubernetes around how its resource model is going to look. Feel free to join that discussion. I can, if anyone wants to, I'll add after the meeting if no one adds, but if anyone wants to link to the upstream RFC, feel free to do that as well. There was an old one. There's now a new one called the Structured Parameters RFC, which works much better with Cluster Autoscaler and Karpenter. But there's a bunch of work that we need to do there, both to figure out how we want to handle our extended resource model, which is happening in the doc, and then also how we want to, like, doing the POC around DRA. I think it'd be really interesting if we could get like a small group of people that was interested in doing a POC and building out the POC for DRA in the upstream Karpenter project. That'd be great, considering they're trying to target the beta release of the new version of DRA for 131. So I think if there's not already an issue open in the upstream repo, we'll open one. And then if anyone's interested, you can feel free to basically ask to be assigned over there, and we can start to try and build out a POC.
I think for supporting DRA/extended resource, there's like a issue that wrapped the two together. We can link that. I don't remember where it was upstream. And we can split that out into DRA versus extended.
Sorry, say that again. What the last thing you said?
It's like
Carmen?
custom resource is the issue, I think. It wraps both the DRA and extended resource onto one issue. Yeah, on the bottom, I think maybe the mega issue.
This one.
We can likely break that into like a DRA specific and extended resource. That's like a super long thread, but there's some talks of DRA and some talks of extended resource here.
Yeah, I do think they're definitely like, I think we can decouple them. I mean, they're
Yeah.
coupled in some ways and decoupled in others. Like, I think that even if we solve this problem, we don't solve the way that we're gonna have to reason about DRA, obviously.
Yeah.
I think we can also reason about DRA. Like, we can first class support for like some of the NVIDIA hardware that is going to come out, most likely, considering who's driving the project. The NVIDIA hardware that's going to support dynamic resource allocation, and just directly support that without solving the extended resource problem. That's still going to probably give us some gaps potentially. So I completely agree. Like, we should consider decoupling them, because I think we can build out a POC with the existing NVIDIA hardware first class and use that as a way to directly integrate that with the project.
Yeah, for sure. I think DRA is likely more defined in how you integrate versus the extended resource, which is much more unknown and why or open.
Yeah. I think that, yeah. I know that there's already been discussion with the working group on this topic. We keep bringing it up over and over again. It's always this conversation of like, we don't want to have like the sprawling set of configuration that is just a grab bag. So it's like, how do we both support like everyone's use cases around this, but also like don't make the configuration just absolutely unreadable and unnecessary? I still don't know the answer to that question. But yeah, I think DRA will hopefully be a little bit easier to do from the at least from the perspective of the things that we already first class support. We can just pass those things down and make it a little bit more like tangible. Garvin, was that something you were going to open an issue for?
No, I did not. I think Bryce was interested. Bryce, sorry. I don't know if it's here today. But
okay.
Yeah, I can open the issue separately.
Yeah, I mean, if somebody wants to open the issue, I'm happy to open it as well after the meeting. It doesn't matter. Anyway. Cool. Moving on. Victor, how does multiple Karpenter controllers work? Chart is 2 by default, but only one is active. The documentation isn't much detail on it. Follow-up question: how should metrics be scraped when using multiple controllers? The documentation encourages us to use this service.
Maybe I can expand on that. It was just, so I'm not really at all an expert on Karpenter, just an end user on eCase. And as I was setting up metrics, I got an issue. Basically, I used most of the default configuration. And I tried to scrap metrics and it was not working. And I figured out at the end of the day that it was because one controller was active and I was scrapping metric through the service. And so it was a 50-50 split of the coin, whether you were falling on the right pod or not. And so metrics seems to working, and suddenly they seems to not work. And if you use all the default, use the mchart that is 2, and you follow the documentation for metrics that encourage you to use the services to scrap the metrics, then you will fall into my cases where you will have some issue. At the end of the day, I reduce the replica to 1. And I wasn't sure exactly of the implication of this choice. And I think someone answer below. So I think it's not really matter because all the nodes created by Karpenter are not deleted, even if for some reason the Karpenter controller is killed or whatever reason, the nodes stay up. It just make it unable to scale to create a new node claim if there's new workload, if there's no node controller, from what I've seen. It's just like a remark, at least, on if you follow the setup for default, there's something that's not really clear, and I think other people that, like me, could fall into these cases where they don't really understand what exactly is going on. So yeah, not really a bug in itself, but still.
Remind me, my understanding, and this could be wrong, and I think some of it depends on how you configure Prometheus, it's my understanding. Because I think by default, the service monitor, it basically uses the service as a mechanism to do endpoint discovery. So the service is just, I mean, like I guess kind of like it is in Kubernetes in general. It's like a proxy for figuring out all the underlying endpoints that are being selected against. So whether you use the service monitor and directly use the service to discover those endpoints, or whether you directly annotate the pods with the Prometheus IO/scrape annotation, it should discover like all the pods that are selected against, and then use that as a way to like pipe through the metrics and scrape the metrics across all Karpenter pods. I think that is the case unless I think there's a way, I'm assuming this may be what you're referring to configure Prometheus in a way that like directly hits the service, which obviously causes problems because, like you were saying, if the pod that it chooses in the round robin is not the active pod, then you're going to continually get metrics that are 0 effectively. I mean, I don't kind of asking you like what your configuration is in like an open forum, but I think my understanding is there's a way to configure Prometheus in a way that should just do the endpoint discovery. That's like the out of the box support with service monitors, but maybe there's some difference in the way that you configured it. I'm not sure.
I'm not sure clear on that one either, because I think I use like kind of fairly default setup. It's just a static config, and I just hit the service as the host to scrap, and it hit on the metrics endpoint. And the inactive pod within the controller Karpenter is still answering on the metrics endpoint, and it's not sending 0 for all metrics. Like on the metrics endpoint for the inactive controller, there's still some metrics as well. And in my setup, at least, when it was falling on the inactive pod, it was not scrapping at all the metric from the other pod that was active. And I could check the endpoint manually to check. So Karpenter was still sending the metrics, because if you check it manually, it was working fine when you check it manually. So I see some people are writing stuff.
I'm taking notes about this question because it's also relevant to what we're using. So, this is something I've wondered about personally.
I'm curious what you mean, like wondered about what specifically?
Oh, specifically like if so we're using Datadog, but like what you're describing with service monitors and Prometheus should work the same way, in that I'm annotating the service resource to tell Datadog to scrape off the service rather than like by annotating the pods. And so in my head, I'm thinking like, okay, the metrics are different depending on which pod you talk to, and I assume that works correctly because Datadog is set up to like look at all the pods that the service is routing traffic to and then scrape them individually.
Yeah, there, I mean, so my understanding with Prometheus with static configs is that there's two ways to configure it. One way is obviously to like directly hit the service. The other is for it to discover endpoints off the service and then use the pods that it underlying the service to actually scrape the metrics. And obviously, the correct way is the latter one, because the first one will obviously with any HA controller lead you to getting metrics that are unexpected.
Yep.
So I think it's just a configuration question mainly. That's at least my understanding of it.
Yeah, that makes sense to me. And it would throw a lot of like previous metric configuration that I've used in the past that I'm pretty sure are working correctly into question if it didn't work that way. So
So I was checking on the side as well. So Prometheus, it just hits the endpoints that we configure, and it does not have specific logic, at least from the. It's like a static config, and it hits the targets that you tell it to hit, and it does not like do some specific. At least there's nothing about discovery that is set up in that config. So I assume it will be shown if it was the case. But maybe I could lock that on my side, and I think we could.
Yeah, I think there is some documentation. I forget exactly how to get it statically configured, but this is not the documentation. Definitely seen it before. I think there is a slightly different configuration you can use to get it to discover the underlying pods. You could, of course, I mean, if you wanted to, you could just fall back on annotating the pods directly. But I think we generally recommend like use the service monitor discovery, and then that makes it super easy. But yeah, I'd look around for the other configuration. If you aren't able to find it, we can maybe have a chat in the Slack as well, and we'll help you out there.
does the Karpenter Helm chart provide a stock service monitor out of the box?
It does, yeah. You have to enable, I believe it's service monitor.enable is the way that you would actually enable the service monitor to get deployed.
Okay, I will look for those value at least, and
Yeah, I would
hopefully-
start by checking the service monitor that's configured in the Helm chart to see if it's different than what you're currently doing. That's probably a good place to look first.
Yeah. That assumes you're using Prometheus operator, which you may
Yeah.
just be using with Prometheus, just bare bones, but depends. Cool. The last one on this list is
Oh,
warm
sorry.
pool.
I added those links, but then the original question's not me. It's
Oh, I see.
not those links. I just suggest
This is-
those.
Got it. This is just additional context.
Yeah, I appreciate those links. I was the one who added this. I guess I'll have to check out the links because I haven't seen those issues yet. But my understanding is that right now Karpenter doesn't support the ability to have like ready capacity or like warm capacity effectively. And I guess I mean, maybe checking those issues is going to answer this question exactly. But I guess I was wondering, like, what's the thoughts on the possibility of adding that support, I guess.
As someone who's implemented this in the past with Cluster Autoscaler, you can use kind of like what we've called over provisioning pods, which are effectively pods that are designed to just get preempted immediately anytime anything else scheduled in the cluster. And then they will become pending again. And then Karpenter or whatever cluster autoscaler you're using at the time will then provision additional capacity to schedule them. And then they'll just get punted again, like over forever. So effectively they act as a buffer.
Right. Okay. Yeah, I think right now we're doing something similar to that by having effectively that just a deployment that has an anti-affinity against pretty much everything. And then gets preempted as an incredibly low priority. I know that AWS supports like hibernated instances and like warm. There's AWS warm nodes, I believe. Basically, just ways to enable like much more rapid auto scaling, especially when we have like a big spike in incoming traffic. We want to react to that quickly, and even with having a couple of nodes say over provisioned, it can still end up you're waiting like 5-6 minutes for a node to come up and be ready.
Yeah, that was going to be my first question here was going to be, what do you mean by warm pools? Because those are like, there's two, I guess, yeah, no mind, there's two concepts of warm pools. There's like warm pools, which are what Matt's talking about, which are like your nodes that you've provisioned that are immediately available because they're already running. I mean, you're getting charged for them and maybe they're not running any capacity, but they're like going to be the quickest form of like, okay, now I have a scale up, my application's ready. And they'll immediately preempt the existing pods on those nodes and they'll be scheduled and it's basically instant. And then there's no like warm pools inside of AWS, which are like the instance is stopped. I believe it's either no cost or reduced cost for the instance. And then we're able to then start the instance and spin up the node at that time, but it's going to be a little bit slower, but your costs are probably reduced. Like which one are you looking for?
Like probably the second, like the ability to have like stopped or hibernated instances that Karpenter's then able to just like, or either it manages or it's able to take over and start in order to satisfy autoscaling requirements. But even in the case of just having like nodes that are sitting there empty and ready to go, some way in Karpenter itself to specify like a certain amount of capacity ready to go would be more convenient than having these like over provision pods, for example.
I don't know. I don't know if I want to, Guy. I don't know if I want to throw you under the bus because this has some overlap with what how Cluster Autoscaler has been thinking about this problem, and I figure you might have a little bit more context into it. I mean, I've had some discussions with Maciek on the Cluster Autoscaler side around like I believe it's provisioning request.
Yeah.
Yeah, because the Cluster Autoscaler has done some thinking about this, but I think we kind of there's like a separate question of like, should we align the APIs around how we do this? But I do think like the same problem exists in both projects fundamentally. Like I need to represent my application pods. There's some like tangential problems around that, around like, I also maybe want to represent atomic capacity, but just like bare bones, the question is like, I want to represent additional capacity. I don't want to, like, I want to easily represent additional capacity and I don't want to have to deal with these negative priority pods, which mostly for, I guess, scheduling complexity around having to like do the calculation, the preemption, but I don't know what your take is.
Yeah, so at the moment, the provisioning request, like most of the code is actually in the CA. It's behind a feature flag that's defaulted off. I'm just trying to find if we create a enhancement proposal for it or what we did. Yeah. Yeah. You've pulled it up. Yeah. So it's a bit more focused on the sort of all or nothing. Like that was the use case that was mostly been thought about of like gang scheduling, rather than the default of the what I've called internally packing peanuts and stuff, of like those low priority pods and then kicking them all. So that's been the major focus of answering that use case. Given that I'm not sure how well it'll work, because you'd need to potentially rerun things, I think. But I'm not sure from the conversations I've had whether it will fully solve the problem that you're sort of mentioning here. I don't think it's been fully agreed on, and this is part of the reason why it's currently still beta and default off.
It's a slightly different use case, right?
Yeah.
It's not serving a surge. It's kind of
Yeah.
serving something that you know is going to land on the cluster. And one thing I want to mention that wasn't obvious to me when I was looking at this, provisioning request lets you define the shape of the things to come so that they will be actually properly simulated, and Cluster Autoscaler or Karpenter can provision the right infrastructure for what's coming, right? So it's not just a request for n nodes or like certain number of compute, which is, I think, is pretty valuable in some cases.
Yeah, it's very focused on that. Like, I know the shape of the workload rather than the shape of the compute I want, and then still letting CA do the traditional thing of picking the instances based on that shape of thing.
I think the thinking is probably right around it being like your future capacity being based around your application. Versus like, because the reason you're thinking about scaling up your capacity is most likely because you think you're gonna have a surge in a given application. So I think at the end of the day, like I think that piece is probably correct, like representing, and the reason I brought this up is because I question whether there's a way that we could perhaps attack both use cases. Maybe that's too much, but like with, I think this can evolve. I'm hoping this like provisioning request can evolve in a way that like can be utilized one by both projects, and then also can hopefully meet more use cases beyond the very focused one that it is right now. I do think the application modeling on future capacity is right. There's a bit of a question around when you scale up and surge into that over provisioned capacity. Do you want to then utilize up that over provision capacity in a way that it's like a buffer and then that buffer gets filled? Or do you want to then extend your buffer based off of like, because over provisioning pods basically will consistently always extend the buffer above and above. Which I think you probably still want to continue to extend that buffer if you're just trying to make sure that your application pods scale up quicker, but then you're paying more, obviously.
They're different, though, right? I guess like it's like buffer versus Slack, like having some Slack or warm pool versus something that's always additional to your current capacity, which is like a buffer, but Slack, like, oh, I always have a trailing number that fills up, but then doesn't have to regain the Slack. If that makes sense.
Yeah, I guess the question is like, what would the like common use case want? Like, would the common use case want that additional buffer to always exist, or to actually just like surge into the buffer and then like at the point they hit the buffer, then they'll just get the static capacity as it comes?
I can say for us, like it might depend a little bit on the workload, but one example is like we use a ton of like GPU instances, and being able to keep a constant buffer of GPU instances and then effectively be able to get like early detection of when GPU instances are unavailable or like their capacity is all used up would be really valuable. Like, so having a pretty much a consistent buffer of GPU would help us scale up, and then would also help us like understand, oh, we're actually not able to provision more GPU in like this AZ or this region or something like that.
Doesn't that require the AWS to actually like provide that information of like, here's the available like amount of GPU that's not currently in use in a given region or AZ?
Well, if Karpenter's like, if you scale up and then Karpenter instantly requests a new GPU node and it doesn't come up, then you know, right? Like,
yeah, but that's not good enough for what we're trying to solve for your use case, right? Because you want to know ahead of time, like when that's coming. Like if you saw that like the GPU instances in like the Dublin region were like trending downward, like that would potentially cause you to make some decisions about how you're trying to allocate your software in the cloud.
I get, is the reason you want the buffer is it for the use case that provisioning request is trying to meet to some degree? Like it's like I'm trying to make sure that I have like capacity available so that like when I run my AI ML jobs in like a gangster kind of approach, they'll schedule.
I mean, overall, we have a bunch of different use cases. Like we have AI ML jobs that would need to scale up. They're inherently slow to scale up, especially if a node needs to start, because we can't like we can't like pre-buffer those nodes with the required images and stuff like that, which can be upwards of 10 to 15 gigs because of the required packages, PySpark, all that kind of stuff. We can bake those into like the AMIs. That again just creates a bunch of additional work, and we have things like, what are we using? Kubefledged, which automatically like pushes images out to all of our nodes that are available. But that doesn't help in the like instantaneous case of I need to scale my workload kind of situation. We also have a bunch of web services that need to respond to like quickly to latency sensitive requests and stuff like that. So like it's not just the sort of AI ML use case. It's a sort of a range of use cases, I guess.
Negative priority doesn't help here only because of the configuration burden. Like I think it works as a workaround for what you want today, right?
It definitely works as a workaround for sure.
It's not ideal from a configuration perspective, basically.
Yep. And then you sort of have the question of like, how many of these like sort of over provisioning, low priority preemptable workloads do I run for the different types of workload shapes that I have, basically.
Yeah.
So are you
go for it.
Are you looking to just like represent a percentage based overhead across like at an application level, basically?
So we utilize node pools a lot for this kind of use case where we tend to represent a group of workloads in a node pool. It'd be nice to be able to have either like a percentage buffer overhead or something like that on a particular node pool.
But you're kind of like, I guess, grouping, like, I guess because you understand your workloads, you're kind of like putting everything into a bucket. I guess fundamentally, like conceptually, like this is a property of the application, right? That's I guess what I'm trying to get at is that the application itself, like I guess you run into the same issue of like obviously maintaining over provisioning pods is annoying from a configuration perspective because you have to do it for every application. But it is an application property, right? Like you know that your applications are all sitting together inside of the same node pool, so therefore you want the configuration on the node pool because that makes it easier for you. But like from like a conceptual perspective, the property is on the application, right? You want the buffer for that app.
Yeah. Well, yeah, to a degree. Like, let's say, like we ran into this actually. This is a good example because we ran into it really early when we were testing this out. Was when we gave the developers the ability to control whether or not we called it a warm node deployment in the Helm charts, like just enable a warm node deployment. If they had like say 4 GPU workloads all using the same GPU node pool, and they enabled that warm node deployment on each of those deployments for that Helm chart, then we ended up with 4 additional nodes where we probably don't need 4 additional GPU nodes. We actually just need like 1 or 2. Mm-hmm. So it is in a way a property of the application, but also can be a property of the pool itself.
I guess I had similar asks before, but I think talking previously is like, okay, it's hard for Karpenter to know because the node pools are relatively heterogeneous in like what capacity can bring up. So like saying I need N extra capacity usually doesn't completely make sense in Karpenter. But I think there's something here where I wonder if you understand the overhead of your applications and you say in this node pool, every pod gets an extra CPU memory or some gigabyte of memory or 1 GPU. And that's the buffer that you add on top of when you calculate capacity, you add the extra buffer onto it. That will spin up new nodes to accommodate for extra capacity. And I guess from like you're augmenting like all pods in this pool to be like, oh, I need actually a little bit more to satisfy a slack or a buffer, such that like you bring up the nodes that works with the current application. Hopefully that population is like the right kind to bring up the right kind of nodes. And that way you have some slack or buffer or whatever you want to call it, that won't come down just because of the spread. And then when you do consolidation, you include that extra capacity calculation into the consolidated calculation to not bring down the capacity. It's like not exactly a low priority, but it's just each part is now bigger, if that makes any sense.
Is it too crazy to like, maybe you don't want a replica based overhead, but like, is it too crazy to have like a annotation on the deployment that like orchestrates over provisioning pods as like a simple worker? I know it's not ideal, but like from the ability of Karpenter to reason about if there's like a configuration overhead here.
If you're
With you-
just gonna do over provisioning pods, you could just put that into the like alongside like whatever application's deploying it instead of using annotations and making Karpenter responsible for it.
It's an additional.
But the warming stuff is like the hibernated nodes and stuff. That's like something that's interesting that I think is relevant to Karpenter though.
I guess the warming stuff is similar issue, right? I guess like how do
Like
you
if
know?
you want, or yeah,
So-
if you want to have like a pool of like warm nodes that are designed to be excess capacity for this workload that we know is going to scale up, like I think that's an interesting case. I don't like the idea of putting that at the node pool to say like anything that belongs to this node pool gets that extra buffer, because like who's to say that like application A needs this much buffer versus application B needing no buffer or whatever else. It like makes your node pools like really tied to like each application. But doing something like you could, the CRD might be the best way to handle that, as opposed to just like using annotations on deployments. Yeah, CRDs are heavy, but maybe this is the right case for it.
I guess you still have to replicate. I guess my one concern with over provisioning pods with deployments is you have to replicate the deployment, basically, right?
Yeah.
So you can template it, but you have to double it when you're doing that.
Yeah, that's. I don't think it's like that much extra effort. Typically, you're wrapping this in Helm or something else that makes it pretty easy. But yeah, you're not wrong. We have a couple cases of like an application that needs to be participant or needs to be available in every AZ that is out there, and so we actually have like a coupled deployment to enforce that every AZ is getting provisioned. Like this dummy deployment literally does nothing but have anti-affinity that ensures that it's running in every AZ, just so that the other real deployment has all AZs available to schedule to, which is kind of a hack, but it's honestly pretty workable and can be removed later whenever we solve the underlying issues that force it to be that way.
We have issues with the kube scheduler. That's why I'm like,
Yeah.
like
the other problem that we haven't gotten to yet is if you need that like warm buffer capacity for this application, how do you ensure that that application gets to use it whenever the capacity becomes available? You're now negotiating with a Kate scheduler to try and make that happen. Interesting problem space.
Yeah. I question, maybe this is room for another Google Doc. So we could ideally like start to synthesize these ideas into something that's workable. Because I think there's been a lot of tangential discussions that have happened over the last year on this discussion. I think actually maybe we could track down. I know that Ellis and Jack had a conversation on this, and I thought they wrote their ideas down somewhere. Maybe track that down, because there was some initial discussion on this, and then it kind of got moved to the side, I think, when Jack started working on some other things. But he was originally trying to attack this problem, and I think it might be worth like trying to pick it back up and see where we can get with it. Particularly because it might have some overlap with how Cluster Autoscaler is also thinking about similar problems. Awesome. I think it was a great discussion. We're getting.
Thanks for entertaining that.
No, I think it's a very interesting problem space. There's a reason we've had it open for so long, because it's a difficult question to figure out.
Are hibernated and stopped instances actually cheaper?
I think they are, because otherwise,
I think you only pay for the EBS storage. I think you don't pay for the instance cost.
Yeah, it's not running. It's not costing you anything.
But if you turn it on, it starts like, isn't that instance effectively like reserved for you, kind of?
I don't know
It's
how
like,
they do that, but it
yeah, like
wouldn't
that
cost
just seems
money.
very odd. Yeah,
I think, yeah, it doesn't cost money if it's not running, from what I remember.
but it still has to be bookmarked like in AWS's like
Yeah.
actual infrastructure, meaning that like
Mhm.
nobody else can like take it from you.
No, because the RAM gets saved down to the EBS, I think.
Okay.
So technically, I think you can get into a situation where your
You can't
hibernated
start
instance
your
isn't. Yeah.
instance. Okay. That's an interesting yeah, that's another thing is like, is that acceptable for this for like what we're talking about right here? Is if the instance can't start? Or yeah, I don't know. It's interesting.
Yeah, that's true. Okay, I think we're at the top of the hour at this point. This is really, really good discussion. I'll try and work to track down the doc, and then we can see if we can start formalizing some of those ideas over there, and then point people to that in the Slack, also in this document. But yeah, thanks everyone for attending. We have another working group meeting, I guess, not this Thursday, not the following Thursday, but the Thursday after. I'm not sure what date that is, but so 2.5 weeks from now. So I'll see y'all there. Thanks, everyone.